Hi, everybody. Welcome to chapter 19. So, in this chapter, we're going to be talking about the epidemiology. And your textbook talks about a disease known as puerperal fever, which is a disease of the uterus, typically associated with either giving birth or having a D&C. And it was very common in women in the 19th century. So in the mid 19th century, 1 out of 8 women died in Vienna due to childbirth. So Semmelweis noticed that the incidence of death, or the incidence of infection, I can say, was 4 times higher when the women were dealt with by medical students, and it was much less common if midwives or midwifery students were working with the pregnant women. One of his friends got cut by a scalpel during an autopsy, and he died of symptoms similar to puerperal fever. And so he thought maybe whatever killed the woman, maybe that poison got into his friend. And so maybe his friend actually transferred some of this to other women who were having babies. And so maybe this was something that was happening. Maybe if you can transfer pathogens, some poison, we don't know what it is. It's, again, the 1800s. And so we can't for sure say this is a bacterial infection or something. But let's just say that if it's a poison, if the poison could move from a dead woman during an autopsy to a medical student, then why couldn't a medical student give a poison to the woman that was giving birth? So this is before germ theory. And so we weren't 100% sure of what the poison was. We know that the poison was likely Streptococcus pyogenes now. But he noticed all of this, and he noticed that the midwives and midwifery students washed their hands more often than the medical students. Medical students would come right from autopsies to the women. They might come from a class where they were helping with a surgery to these pregnant women, and they weren't cleaning up at all. And so he suggested washing hands might decrease the incidence of puerperal fever, and it did. It dropped by 1/3 of the previous level, which is really good. Actually, this helped other scientists, Joseph Lister included. He was a doctor, come up with his own techniques for hand washing and for cleanliness and aseptic technique, asepsis. So what is epidemiology then? Epidemiology is the study of distribution and cause of disease. And epidemiologists collect data. They collect data about disease and risk factors for diseases. So this allows them to determine different strategies they can use to either prevent a disease or predict how the disease is going to spread. And so there are a lot of different disciplines included in epidemiology, including microbiology, which is what you're in right now, ecology, sociology, psychology, statistics. So there's a lot of science fields. And epidemiology is what brought about a lot of the aseptic techniques that we see today in hospitals and laboratories in our daily life. So, what are different types of diseases that epidemiologists study? So these diseases can be communicable. So communicable diseases are diseases that can be transmitted from one individual to another, or they can be non-communicable. So if it's non-communicable, it's not going to spread. An example of a non-communicable disease would be botulism. Botulism doesn't spread from one person to another person. If a patient has botulism, they're not going to spread it. An example of a communicable disease, the most common one that is discussed these days, is COVID-19. That's very communicable and can be transmitted from one individual to another. In epidemiology, we deal with a lot of definitions. So let's go through these different definitions. The attack rate is the percentage of people who become ill in a population after exposure. And so this can help us identify how immune our population is, as well as it reflects the amount of microbe that's needed to cause disease. The incidence is the number of new cases divided by the population at any given time. And so this is going to help us determine the risk an individual has of contracting the disease. The prevalence is the total number of diseases or number of cases of the disease at a specific time period in a population. Morbidity is the incidence of that disease. Mortality is the overall death rate in the population associated with that disease. Case fatality is the percentage of the population that dies from that specific disease. Different diseases have a different case fatality rate. An endemic disease is a disease that is always present, so something like a cold. A sporadic disease is something that pops up every once in a while. So an example of a sporadic disease that I've used in the past is measles, but it's becoming more common and more like an epidemic that is occurring, or an outbreak. An epidemic, and that's because of anti-vaxxers deciding that they don't want to vaccinate their child because they don't believe scientists are smart or something. I don't know. That's not something I'm going to discuss right now. An epidemic then is an unusually large number of cases that occurs, and this can be introduced or an endemic disease. So we have epidemics of the flu, typically around between October and January. We have an epidemic of influenza. Outbreaks are a group of cases that occur at a specific time within a population. So in the past, we would have outbreaks of chickenpox. One person would get the chickenpox, and because before you have the actual chickenpox rash, you have a cold-like symptoms, and then you get a fever and a cough. And a lot of times children would be playing with other children thinking they just had a cold. So when you get a bunch of little kids together, second or third graders all playing together, and one of those children has the chickenpox virus and doesn't know it, it would spread. And so this would cause an outbreak. And then a pandemic is a global epidemic. So it's found everywhere. So your example here is AIDS, but another example would be COVID-19 again. So for us to be able to stop an infection, we have to know the steps that typically are followed to cause an infection. So you have to know the reservoir of the infection. You want to know what is the portal of exit. So there's got to be a reservoir. That reservoir holds these pathogens. The pathogens have to be able to leave. They have to be able to transmit to another organism. So another organism has to take it in through some portal and has to be susceptible. So if we know the chain, then we can break the chain somewhere, like right here or right here, and then that infection won't spread. Okay, so I'm going to stop here and we'll talk about reservoirs in our next video. Bye.